Alrighty, folks, I want to take an opportunity here to kind of connect what we're talking about today with mechanical advantage with what we did the other day with our lever lab on Gizmo. So let's go ahead and just set up a pretty simple example on this lab. So I've got my turkey here. I'm going to put it on the other side from the strongman. Now, when we are talking today, we're going to talk about how machines change work. And this is ultimately going to be called mechanical advantage. But the first thing we need to do is what is the work that goes in and comes out? So the work that goes in is called work input. And so this, in this example, is going to be what the strongman does to the lever. So his work going into the machine is the work input. And then the work the lever does on the animal, that is our work output. Okay? So when you think about work, you need to think about work in 3 dimensions. You need to think about work as force, as distance, and as direction. And what a mechanical advantage is how the machine changes the work input. So basically, how is the work output different from the work input? So let's go ahead and show an example of this. So I'm just going to go ahead and have the strongman push down with 100 newtons, which is how much the turkey weighs. So when he does that, you'll see that his work input pushes down on the machine, and then the machine raises up the turkey to be even. So what you're seeing here is the strongman, he moved the bar with 100 newtons of force, and the bar or the lever moved the turkey with 100 newtons of force. That's why it's even. The strongman moved the bar 1 meter down, and then the bar moved the turkey 1 meter as well. The mechanical advantage here is that it changed direction. So you'll see when it was neutral, it was like this, and then when the strongman, he pushes down and the turkey goes up. So that's one type of mechanical advantage, is that you can change direction. So let's take a look at a second type of mechanical advantage. So for this one, I'm going to go ahead and move my fulcrum all the way over here. And I'm going to put the turkey back on. So let's go ahead and try to exert 100 newtons of force again and see what happens. So he's pushing down with 100 newtons of force, and you'll see he cannot lift the turkey. So let's go ahead and up that up to something like 500, and you'll see now that he is able to lift the turkey up. So it takes a lot more force to lift the turkey, even though this bar is only exerting 100 newtons of force, he is exerting 500. So let's go ahead and exaggerate this a little bit and have him exert 1,000 this time. Okay. So what we're going to notice here is that when he's exerting 1,000, the turkey is all the way up here, which is great. But what we want to pay attention to is when he's not exerting, the bar is right over here at about 1.2 meters, and the turkey is here at 0. So when he exerts all of this force, he moves the bar about 1.2 meters, but the turkey moves 5 meters. And what we're seeing here is, in this example, the mechanical advantage is that the lever increases the distance that the turkey moves. So the force decreases and the distance increases. So that's our mechanical advantage, and we're going to focus on the increase. All right, let's look at one more example, and we're going to look at the pig here. All right, so I'm just going to set it equal, and the pig weighs 2,400. So even if we put 1,000 newtons of force, we're not going to lift the pig using this simple machine. So instead, what we're going to do is we are going to shift all the way over here, and we're going to put the pig on, and you'll see the bar goes way, way up here, all the way to 5 meters. So the pig, remember, weighs 2,400 newtons. So I'm just going to put like 250 newtons here, or something like that. And what you're going to see is, doing that, I am able to lift the pig. Now, what I am doing here, that means that this 250 newtons that I went in is more than enough to lift the pig. So I am increasing the force by the lever. So my input force is relatively low, but my output force is much higher. But what you will notice is that my input distance is very, very high, because look, the input distance it starts at 5 meters. I do 250, I have to move it 5 meters just to get the pig to move, I don't know, 50 centimeters. So that would be an increase in force with a decrease in distance. So depending on how you arrange the lever, you can do all sorts of different things with mechanical advantage. And as you will see, mechanical advantage changes the input work in a lot of different ways depending on your simple machine.